Thank you for joining us for Carving Bits 201 Easel Live. I am using a mic today. I know many of you were a little frustrated with some of the sound quality we've been having. Okay, so now, in addition to that, one thing you might notice is that we have a CPR training going on in our office today. So if you hear like a bunch of pounding followed by like very consistent pauses in that pounding, we're just trying to save lives here, people. So I apologize if you hear a little bit of that noise in the background, but that's okay. Hopefully this episode will be engaging enough that you will not be thinking about anything except calculating fees and speeds for your bits. So my goal here today is to try to teach you the basics about calculating feeds and speeds. Now, I'm not an expert. I know you might think I am, but I am definitely not an expert, and I'm learning about this stuff just as much as you guys are. So I have put a lot of really helpful resources down below in the description for you to check out that I think are really educational. Some of them are from us that we've put together based on what people have told us they wanted to learn about. But I've also found a lot of really helpful stuff from some of our some other YouTubers that are out there, CNC Cookbook, OnThread. All of these places have really great resources for learning about feeds and speeds. So I've put those in the description, and hopefully you can access those after this episode or while you're listening to me talk, and can go from there. So the first thing what I want to try and do here is talk about feeds and speeds and kind of what goes into feeds and speeds. And then if we have time after that, I want to talk about V-bits and how those kind of play into everything. I want you guys to know too that all the feeds and speed settings that you see in Easel have been tested by Inventables to find the most ideal feeds and speeds. So when you add in a bit and a material combination, we've tested that bit and that material combination to try to figure out, okay, you should use this feed rate and this step per pass, and you know, these are all the settings that you should use. Now, you've noticed, I'm sure, that there are not a ton of bits in there. And part of the reason is this takes a really long time to test this stuff, and we don't want to set you guys up to fail with bits and material pairings that might not work correctly, which is why learning how to set your own feeds and speeds is really important when you get a bit that you don't have the information about or that's not already preloaded into Easel. So that's what we're going to try and do today, is to show you how you can take information and use that to calculate your own feeds and speeds. So why are feeds and speeds important? Well, there's a lot that goes into figuring this out, but ideally, if you get the right feeds and speeds for your material, you're going to increase the likelihood that your project comes out looking awesome. So in addition to what we talked about in Carving Bits 101, where we're talking about the different types of flutes, the way your feeds and speeds interact with your material is also going to determine if you get tear out or not, or if you cause burning or not. And that's why figuring out how fast your bit should move, how quickly it should be rotating, how deeply it should be carving, all those also impact how your project turns out when it's all done. So I'm going to share with you guys real quick. I found, as much as it might be nice to like listen to me talk, I drew up a few diagrams that I want to show you guys that might help kind of understand like what we're talking about. I'm a big visual person, and it's not something I can really teach in Easel. So I tried to draw up these little Sharpie drawings yesterday. I'm not saying they're awesome. Hopefully we get something up better soon. But in the meantime, I wanted to share these with you so that you have access to them. So this article lives on our support center, and it is called Calculating Your Feeds and Speeds, Basic Feeds and Speeds Information. So there's a couple different cut settings that we're going to talk about, and I'm going to do my best to just try to explain the differences between them so that you can use that information. So the very first one we're going to talk about is feed rate. Feed rate is the rate at which your machine advances along your project as it carves. So you can see here's your spindle, here's your bit, and it's moving this way through your material. So how quickly this bit is moving across your material, that is your feed rate. Feed rate is typically measured in IPM, or inches per minute, and this is only something that impacts your X and Y movements. So feed rate is not controlled by how deeply you cut, it's only how fast across the material your machine cuts. So your Z movements are not determined by feed rate, this is only your X and Y movements. So for example, let's say you have a feed rate of 20 IPM, and you can see here in Easel, the cut settings, right? So this one is 50 inches per minute. So what that's saying is that the machine is going to move along 50 inches in the X and Y direction in the course of 1 minute. So that is pretty darn fast. So that's something to keep in mind when you're talking about feed rate, is that that's basically what that measurement is how quickly along in the X and Y direction the bit is moving. Now, one thing to keep in mind about feed rate is that feed rate is independent of how fast your bit itself is rotating. It's strictly X and Y movements. Calculating feed rate can be a little bit complicated. So one of the features that we've added into Easel is a feature called feed rate override. So feed rate override, if you've not been in Easel lately, this is a new feature. I would recommend watching this short little video before you use feed rate override, just so you can kind of understand what happens. The video kind of shows you like what the machine does and how to use it. But feed rate override allows you to slowly increase or decrease your feed rate while your machine is carving. So you don't necessarily have to get the perfect feed rate calculated before you start a carve. Feed rate override can help you say, okay, my machine seems to be carving too slowly. I'm getting a little bit of burning, so I need to speed it up. Or my machine is carving way, way, way too fast, and I'm worried I'm going to break my bit, and I want to slow it down. So I would recommend checking out this tutorial. Again, it is down in the description of this video, but this shows you a little bit how to use feed rate override and how that works. All right, cool. So those are the basics about feed rate. The next thing, oh yeah, we got like some little text here if you want to read that. The next thing we're going to talk about is depth per pass. So depth per pass only impacts your Z axis, not your X and Y. And the depth per pass indicates how deeply your bit goes into your material every time it starts a new tool path. So you can see in this illustration, this is the depth per pass. This is how deeply the bit went into the material for this tool path. Now, this same distance would then go down here and down here, etc. It's a set variable in Easel. So whatever your depth per pass is at the start of your project is also going to be the depth per pass throughout your entire project. So some programs do have varying depth per pass, but for Easel, it is sort of a stagnant measurement. And it is also measured here in inches or millimeters. So if I go back to my cut settings in Easel, you can see that my depth per pass here is set to 0.06 inches. If I was in millimeters, then my depth per pass would be in millimeters. Doesn't like me right now. Probably I'm taxing it a little bit here. But so depth per pass can be set in millimeters or inches, depending on which measurement you're using. And again, it's just how deeply your bit goes into the material every time you start a new tool path. Now, as a general rule with depth per pass, we recommend not using a depth per pass that is greater than half the diameter of your cutting bit. So for instance, if you're using a bit with a 1/4 inch cutting diameter, your depth per pass should be no greater than 1/8 of an inch. And you'll learn a little bit more about why that is later on in this Easel Live episode. The next, oh yeah, and there's like this helpful text here if you want to learn about, you know, how to increase the efficiency of your depth per pass based on how deeply you want to carve. There's a nice little description here, but I'm going to skip through that right now and just kind of like give you guys the basic concept about what depth per pass is. The next thing I want to talk about is spindle speed. So spindle speed is the rotational speed of your bits measured in revolutions per minute, or RPM. So I know this is a kind of a touchy subject for everybody, but we recommend only leaving your DeWalt spindle on your X-carve at like the first setting. And I know a lot of people like to push it. A lot of people like to go like 2, 3, 4, 5. But we like to leave the DeWalt at 1. There's a couple reasons for this, but the most important one is that the rigidity of your machine is not really designed to like handle all the other things that go into calculating your feeds and speeds for getting a really nice cut at a high RPM. So if you really want to maximize how clean your cuts are, it's important that you keep your spindle speed set to the first setting on the DeWalt, which is still like 16,000 RPM, which is still pretty high. And most of the projects you want to do, you can do at that spindle speed. The other reason is that, as I'll show you later on, the equations for calculating feeds and speeds can be a little bit complicated when you start factoring in chip load and feed rate and rotation per minute. So having a variable that you leave constant at just 16,000 RPMs for X-carve is really, it's going to make things a little bit easier as you're trying to determine what is the right chip load or what is the right feed rate. So we like to just leave that variable constant to make the equations a little bit easier to calculate. The other reason is, and we'll get into this, a lot of the chip load readings that you're going to get from manufacturers are way, way, way higher than what your X-carve or Carvey are going to be able to do. A lot of these companies that sell us our bits are also selling bits to industrial CNC mills, and that is not that is not something that the X-carve or the Carvey are designed to handle. So you might see chip loads that are way, way, way higher than what your machine is going to be able to do. So it's important that you just kind of understand the capacity of your machine, and that'll help make it a little bit easier to make sure that you don't do anything that's a little bit too aggressive. So 1600 RPMs for the X-carve, that's the first setting on the DeWalt. For Carvey, it's even easier. You don't really get to control your spindle speed at all. It is set to 12,000 RPMs. So those are the two settings that we recommend using for that. And I'm going to talk a little bit more about why spindle speed is important as we talk about chip load. So chip load is something that was kind of a puzzle for me. I've not spent a lot of time trying to understand chip load, and in the last week or so, I really dug deep into the subject, and I've watched a lot of different videos trying to figure out what chip load is, why it's important, how it factors into all this other stuff. And the resources I used for my learning are also down below. Please use those resources. I'm not saying I'm an expert, so talk to some people who are. So chip load, I'll go into our little thing here. Chip load is basically the thickness of the material that's removed every time your bit makes a rotation. So every time one of these flutes digs into your material, this space here, the length of this bit is what is indicated by your chip load. So it is the thickness of the chip that is formed while you're machining your material. So chip load is interesting because this little piece of wood or metal or whatever plastic that you're carving, this is a direct outcome of your feed rate, your spindle speed, and the number of flutes on your cutting tool. So this chip is determined by how quickly your machine is moving across the surface of your material. That's your feed rate. How quickly your bit is rotating. That's your spindle speed or RPMs. And how many flutes are on your bit. In this case, there are 2 flutes on your bit. So why is chip load so important? The most important thing to know about chip load is that when your machine is carving, and this thing, like I said, 16,000 RPMs, that's pretty darn fast. Even if it might not seem that fast compared to what your machine can do, this is generating so much heat as it's moving. And as your machine is producing these chips, it's not just removing material, it's also expelling the heat away from your material so that the bit doesn't get too hot and your material doesn't get too hot. So having too much heat in this area where your bit is carving is the #1 leading cause of dulling your bits. And we all know that buying bits is not fun. You want to get the most life out of your bits as you possibly can so that you don't have to just keep buying a new one every week or every 2 weeks or however often you're buying your bits. So generating too much heat means these bits are dulling even quicker. And that's just going to mean you're just going to have to buy bits all the time. And we'd love for you to buy bits, but we don't want you buying bits that you don't need to buy. We would much rather have you carving successfully and getting the best value out of the bits that you do purchase. So it's important to balance this because if your chip load is correct, you're going to be expelling heat away from your bit, and that's going to keep your bit nice and long lasting. The key to chip load is balancing the stress that you're applying to the bit by the bit moving forward with the heat that's generated by the rotation of rubbing against the material. So a good evenly sized chip is going to expel that heat around quickly, and you're going to have really long life out of your bit. If the chip load is too small and you're creating dust, that's going to be the #1 cause of your bit deteriorating too quickly. And there's actually a name for it. That name is called rubbing, or also burnishing. And if you're creating dust, you're creating too much heat and your chips are not efficient. So if your chip load is too small, that's where you're going to get this rubbing and burnishing. In one of the links down below, I share a video from CNC Cookbook, and Bob Warwick is like, he is the bit master, and he has this great video about why rubbing and burnishing happens. And he's got these really cool diagrams that helps kind of illustrate what's happening when your bit is rubbing. But essentially what's happening is you're feeding your machine too slowly for the bit to really like dig in there and chip off the material as it goes. So it's sort of just like rubbing and dulling the edge of the bit, like the really sharp part. And you're just creating dust. Like essentially you're just wearing down your tool without making a lot of progress. So if you're having that happen where your chips are too small, the thing you want to do is you want to try to increase your feed rate. So you want to try and get your bit moving quicker across the material so that your flutes can kind of dig in. I don't know why I keep doing this. This is like a weird dance move or something. but this is my flute dance, if anyone's wondering. So by increasing your feed rate, you're increasing the capacity for those flutes to really dig into the material, remove the chips, remove the heat, get that stuff out of there, and move along really smoothly. So I know I just like talked a bunch about that, but it's complicated. And so here's kind of like a summary of if your chip loads are too small, you're going to get this rubbing and burnishing, you're going to dull your bits, and you're going to create too much heat. So the best way to increase your chip load is to increase your feed rate, decrease spindle speed. If you're running your machine at a higher speed than the #1 setting on the DeWalt, I would recommend decreasing your spindle speed. Again, how quickly the rest of components of the X-Carve can move in order to keep up with some of those RPMs is not going to be the best way to get a carve done quicker. I'll put it that way. So try to keep it at the 1. You can't go any lower than 1. So in that case, work on increasing your feed rate. Now you can also use fewer flutes. One of the reasons that that's the case is if you have fewer flutes on your bit, it means your chips are going to be larger because it's only knocking off a certain segment. So you can see here, if this had 4 flutes on it, you're chipping off a little bit each time, but having a bigger flute allows you to get, by the time this bit rotates around again, it's taking off a bigger chunk each time. Now, the other thing that can happen with chip load is that your bits are too big. And that does happen too. I am a common proponent of having my chips be too big. And that is because I want to get things done faster, right? That is, everyone wants to do that when they're carving. But it's not going to always end well. So the #1 cause of broken bits is that your chip load is too big. And basically you're trying to remove too much material at one time. So in our case, the best thing to do is try to decrease your feed rate. So basically you're trying to remove flutes too quickly because your machine is moving too quickly across the surface, or maybe your spindle speed is too slow relative to how quickly your machine is moving. So I would not recommend increasing your spindle speed. I would recommend trying to decrease your feed rate first, or use more flutes so that you're carving out smaller chunks of your material at each time. The other thing that can happen when your chip load is too big is that you can cause tear out along the cutting path. So you might get a really bad edge finish if your chips are too big. It's just kind of like clonking through there. It's not really making a nice, smooth, even cut. Or you might end up with bit deflection. Bit deflection is not something we're going to talk about in this episode, but CNC Cookbook, they have a lot of great resources on bit deflection as well. But it's essentially when your bit is, your bit is moving in the tool path because it's being, there's too much pressure from the material it's trying to plow through. In some situations, you might find that your chip load might be too large because you're carving too deeply. So if your depth per pass, I'll scroll back up here. If your depth per pass is too big, that's also going to cause bit deflection because your bit is too far into the material for how rapidly it can remove that material. It's basically just putting unnecessary stress on the bit. So if you're having tear out, or if you're having poor part movement and some of that bit deflection, that could also be a result of your chip load being too big. So those are kind of the basics about chip load. It's kind of a brain puzzle for me. And if you're new to using bits and calculating your own feeds and speeds, you might find yourself in sort of a similar situation that I was when I was doing all this research, but it's just like, I just want to know where to start, right? Like I vaguely understand these concepts and like I sort of know what I'm doing, but like I don't really know when I get a new bit, like how do I start figuring out what the right feeds and speeds are? So that's kind of where some of the things I've talked about kind of come in handy, right? So if you keep your spindle speed constant, it's one less variable you have to worry about. So keep it at that 16,000 RPMs on your DeWalt. That's the first setting on your DeWalt. Keep it at that, and then that's like a baseline, right? So you know where you're at. So from here, the only variables you can change are now feed rate, depth per pass, and chip load, which is kind of related to feed rate and depth per pass. So it's sort of it's an outcome of your feed rate and your depth per pass and your spindle speed. So chip load is an effect of your other three settings. So what we recommend doing when you first get a new bit, you're trying to figure out what to do, start with a faster feed rate and a smaller depth per pass. So basically what you're going to do is by lowering your depth per pass, so you're not carving down very deeply, but by keeping a faster feed rate, you're going to minimize chatter. You won't have any of that bit deflection going on. You won't be removing too much material too quickly. And it also minimizes the rubbing and the dulling of your bits. So it's just kind of a good way to test, like, okay, if I've got a really shallow depth per pass, I already know I'm not cutting through too much material. And from there, slowly increase your depth per pass. Now that does mean you do have to kind of get started with, a baseline of every time you want to set a different depth per pass, you've got to start a new carve. But there are equations that can help you with figuring out exactly what to do for those starting points. So if I go back to my article real quick, and again, this is covered in like every feeds and speeds information you can possibly find on the internet. They'll have these equations for you. So definitely make sure you check those out. But the helpful ones here, I've got them at the very bottom down here. So feed rate equals spindle speed times chip load times number of flutes. And then you can kind of manipulate this equation in various ways, right? So chip load equals your feed rate divided by your spindle speed times the number of flutes on your bit. In most cases, you can find chip load information on the manufacturer's website. So if you bought a bit from Entreprenuer or from many of these other companies, a lot of times they will have this information for you. So as just an example, here is the Entreprenuer site. This URL is down in the description of the video. But they have a ton of different chip load information here. So depending on basically like what you're cutting and what kind of a tool you're using, they kind of give you this information. Let me see if this will pull up and not be too gross. Okay, it's a little gross. And this is probably why people get overwhelmed, right? Because you see something like this, you're like, I don't know where to go. But they do have a really helpful video that walks you through how to use this chart. They've got their bits over here. And then this is to talk about like, okay, if you're using a 1/4 inch bit, let's see if this is not zooming very well. Yeah, that's a little bit better. So let's just take this first bit, right? That's easier. So this bit, this is the product number on their website, and you've got the 1/4 inch bit version of that. They're saying that your chip load, your chip should be, about 0.007 to 0.009 inches thick. So you can take a pair of calipers, measure those chips, and use that. Or you can kind of say, okay, I know my spindle speed on my X carve is 16,000 RPM at the first setting because Mo kept saying that in that Easel Live episode I watched. So you can use that as a variable, a stagnant variable in your equation. And then, yeah, you can see they've also got the same formulas down here. These formulas are universal, so you will always be able to see these. So you could say something like, okay, I know that I've got 16,000 RPM, and it said 0.007 is the low end of that bit, and then I'm using a flute with 3 flues. And if you calculate that, that will give you what your feed rate should be. Now, again, it's kind of important to know the limitations of your machine. And I think I've talked about this a little bit in this episode, but a lot of these manufacturers, especially Entreprenuer, I mean, they're selling these bits to people who have massive CNC mills, and it's going to be what those bits can do on those machines is much different than what the bit can do on your machine. So it's important when you're calculating this and you get a number that's just like outrageous, you should probably use a little common sense and be like, I really don't think my machine can go 150 inches per minute. That seems a little extreme. Maybe I'll tone it down and I'll try like 50 inches per minute and see how that goes. And when you're doing that, again, keep that shallow depth per pass just so you can kind of watch what's happening. As a general rule, I'll just share this. For hardwoods, the best thing you can do to minimize the chatter and the tear out that you're seeing is to increase your chip load by increasing your feed rate. So that's a good way to do that. And then also decreasing that depth per pass. And even though it does take a little bit longer, I can promise you, if you're using a shallow depth per pass and a slightly higher feed rate, you're going to minimize tear out and you're going to have less cleanup to do. I would also recommend using a downcut bit on hardwoods, because then even though you're pushing those chips back into the material, you'll have that nice clean finish edge. And as long as you're not cutting too deep, your bit won't get too hot because it's not trying to remove too many chips. If you're using plastics, the biggest issue that we see when people are carving acrylic or HDPE, you get like that gunky plastic stuff that just sticks on your bit, and that's a result of too much heat. So your bits are generating too much heat. Make sure if you're carving acrylic, you're using the absolute slowest possible spindle speed you can possibly use. Having that bit rotate faster is only going to cause more heat and more issues for you. And then slowly increase your feed rate to increase your chip load. So that will just push that stuff right out. And upcut bits are a great tool if you're trying to clear out heat quickly, because as we talked about in Carving Bits 101, they just lift those bits and they just fleck them right out of there. They're gone. So that's kind of a basic overview for hardwoods or plastics. Plywoods, I would also, we do have those pictures that we showed last time, but treat them sort of in a similar way, right? So always start with a slightly slower depth per pass and a slightly higher feed rate, so that you can kind of make sure that you're not going to cause tear out. It's a lot more likely you're going to get tear out on plywood, right? Because it's just like all glued together and stuff. So that's kind of a basic overview of feeds and speeds. I know it's not great, but I hope it kind of gives you this conceptual view of what is happening every time you do a carve. And those resources, again, are all down in the description, along with some other resources I used when I was trying to educate myself for this episode. So I hope you'll find them useful. There's something else that I want to talk about, and I think I have time to talk about them. But I want to talk a little bit about V-bits. V-bits we addressed them a little bit in episode 1 of Carving Bits 101, but we haven't talked about them a lot since then, because up until this past October, just a few months ago, you couldn't use V-bits with Easel. And now with Easel Pro, you can use V-bits, and it's great because all the complicated stuff that goes into figuring out your feeds and speeds for your V-bits is something that Easel Pro automatically does for you. Now, there are still some things that you want to try to be aware of, and I'll get to those in a little bit. But for some people who don't know what V-bits are, we do have a really helpful resource in our support center that can help you understand what the V-bits are. I'm going to close this stuff from OnThread. Okay, so this article is Designing V-carve Projects in Easel Pro. We also have another one here called What is V-carving? So essentially, V-bits have a V design on them that allows you to generate tool paths with a varied width. So the carves start off very narrow. All right, where do I got those pictures? I got so many pictures, you guys. Okay, so you can see here, the bit starts off really narrow, and then it slowly gets wider the deeper you cut into it. So if you have a V-bit with a 60-degree bit, you can see that right here, you can see how this 60-degree bit can carve deeper than a 90-degree bit, because of the angle of the bit. So generally speaking, the lower the degree of your V-bit, the more detail you can achieve. And the reason that is because with a smaller degree, you're able to carve deeper into the design before the design's limitations prevent the bit from carving down any further. By the same example, a 30-degree V-bit is going to carve even deeper than a 60-degree V-bit because this angle is even narrower, and it allows the bit to carve deeper before it surpasses this width variance that is limited by your machines. So if I scroll down here, there's a few different examples that we have of what that might look like, right? So this picture here, this is a 30-degree V-bit. And you can see, I set this up in Easel Pro, and 30 degrees, you can kind of see what that looks like, right? There's a lot of bottoming out here because the bit is able to carve down deeper because the edges are not, they're steeper. So the bit can get down in there, and you can even see in this, like how deeply it can get into some of these grooves. As opposed to the 60-degree bit, there's less bottoming out. You can tell that this edge is a little bit less steep, right? Like some of the areas like this dragon's body is not even bottomed out, whereas here it was. So the bit cannot carve down as deep before it reaches the outline limitations that are in Easel Pro. So the bit will know, okay, I don't want to exceed this size space, so I'm only going to carve down as deeply as I possibly can before I hit the edges of this design. Now look at this one. Look at the 90-degree. This is crazy. There's no bottoming out in the wings whatsoever. And even though these are all set to the exact same depth, right? This project is exactly the same. The angle of the bit is basically determining what the final product is going to look like. So using a 90-degree bit, you'll be able to clear a lot more material, but you're not going to be able to get as fine of details in some of these areas that you might get elsewhere. So a 60-degree bit, you get a little bit more detail. I mean, look at these little talons and stuff. They're deeper into the material. And then a 30-degree bit is even more so, even deeper. So knowing how to choose the right angle can be a little bit complicated, but the high definition preview that you'll find in Easel and Easel Pro kind of helps you to figure out what that project is going to look like based on the degree bit that you select. And that's easier than not. We have the 60 and 90-degree bits already preloaded into Easel Pro, but you can also add in the bit. So maybe I have like a 30-degree bit, and the total width of that bit is only, you know, 1/4 of an inch instead of a 1/2 inch. So now it knows this information, and it'll be able to generate based on that. So that is a kind of a helpful article if you're trying to just get started with V-bits. Some people would be like, okay, so I don't really know when I want to use a V-bit. You know, why would I use a V-bit over a regular bit? Well, great question. And it's something that until I started using V-bits, I didn't really understand the answer to that. But there are 3 instances that I can think of when you would probably want to use V-bits. The first one is when you're doing anything with like requiring a varied width and depth across the same tool path. So like this GIF is kind of like a good example of that, right? So text is an awesome example of when you would want to use a V-bit because, you know, some elements of this text are wider than others and some are really thin. So rather than try to figure out a way to carve all of this with a 1/32 inch bit, the V-bit will automatically do this for you, and it'll take care of all these varying widths and set them to the right depth that it can carve simply in one tool path, maybe 2. And that's awesome. So that's a great way to really save a lot of time and a lot of hassle in carving is by using a V-bit for complicated kind of scripted fonts, or anytime you've got a lot of little itty bitty details. So this Detroit tiger, I'm from Michigan, so, you know, bear with me. This is kind of another example. Like, look at this tiger's face. Like, there's all these little tiny details that would take, I'm not going to try to guess, but it's going to take, I don't know, an hour, 2 hours to carve all that out with a 1/32 inch bit. And who even knows how long it would take me to carve out this part of the logo. So using a V-bit, it can carve this pocket out nicely, and it can also carve this out nicely. Or you can also use a V-bit as the detail bit in a normal project. So if I go to use an additional bit, it's going to tell me that you should use the V bit as the detail bit, which means now I'm going to use like an 1/8 inch bit for my pocketing, and I can just use my V bit for the details. And it's going to generate those two different tool paths. It's a 2-stage carve. We have a lot of information about that. I know we've talked about that a few times, but you might also, the piggy bank article episode where I talk about the new easel features, 2-stage carves was one of those features. So that's kind of a helpful guide if you're just learning how to use 2-stage carves, but it's a good way to save you a lot of time if you have a really detailed project. And I have this little picture here that really helps to illustrate the difference between using a smaller bit and using a V bit. So in this picture, let me see if I can zoom in. We carved this design here on the left, we carved with a 1/16 inch bit. So it's not even a 1/8 bit, like a 1/16 inch bit. This still took quite a bit of time to carve this because, you know, you still got to fill in these pockets and it's still really detailed. You can see though, even some parts of the element, the design, it couldn't carve it, right? It couldn't carve this part of the W. If you've ever used the Lavanderia font in Easel, you know this problem well, right? It's almost impossible to get that font to carve out really nicely unless it's ginormous. So, but then look at this. Look at the same text with the V-bit. The V-bit can account for these varying thicknesses. So the E is thick enough here, but then it gets really thin in this area. The V-bit just accounts for that by moving adequately in the Z direction so that it doesn't, it can carve that narrow part, but also carve this deep part. And that's what's important to know about the V-bit is that the tool path itself is entirely different than what you're getting with just normal 2D cuts in Easel with a flat bit. The V-bit is moving in all 3 directions at the same time. So it is true 3D carving in that the X, the Y, and the Z are moving independently of each other. So when the bit is carving this, it's going to carve deeper in the wider areas, and then it raises up in the Z to carve this thinner area. So that's really what's giving these different depths, the varying widths in the project. There's a few other little examples here to illustrate, right? So in this one, we've got this little stem that goes to the leaves, and leaves are all cute and stuff like that. But this 1/16 inch bit can't, it's too big to be able to carve out that line effectively. So Easel just won't carve it. Easel will never carve a project that exceeds the diameter of the bit that you're using. So in this case, the stems are smaller than 1/16 of an inch. What do you think about it? That's super tiny. And so the bit can't get in there. So it won't carve that part of your design. The V-bit, on the other hand, it can carve all these little intricate details that you're not able to carve with just a regular bit. And so just as a reminder, this is done in Easel with the 1/16, and this is done in Easel Pro with the V-bit. And this was done with a 90-degree V-bit. I checked with Sam, my friend Sam, who did this up for me. So again, these articles are available on our site. So the What is V-carving article talks a little bit about the basics of V-carving, when you would want to use it. It's got this helpful diagram. And then if you're interested in really trying to figure out like how to design a specific thing in Easel or Easel Pro with a V-bit, this is really helpful for doing that as well. There's also some more diagrams down here that shows if you've got like a pocket, right? The 30-degree bit still is able to get more details because these can be a steeper edge on these raised fonts, as opposed to the 60-degree bit. You can see it doesn't quite make it all the way down into some of these gaps. Or the 90-degree, same thing. There's steep. So these diagrams are really helpful if you're trying to understand what V-bit should I use in a certain situation and what are the difference between the different degrees. The one last thing I want to tell you guys, because you might be like, oh, I don't want to use V-bits. I don't have Easel Pro. Anyone can design any project at any time in Easel Pro. So you don't need a membership in order to use Easel Pro. You can design in Easel Pro, any project that you want. Go for it. You can check it out, see what it does, understand kind of like how V-bits work conceptually. You can always design in Easel Pro. If you have an Xcarve or a Carvey, you get 4 free carving days every month. So you can choose what days those are. Maybe you carve every Saturday for the month of February, or maybe you carve Saturday and Sunday like every other week. Maybe you carve on Wednesdays, maybe you carve on Thursdays, you know, so every month you get 4 new free carving days, which means if you can design a whole bunch of stuff in Easel Pro, and then you just like start cranking out your Easel Pro projects on maybe a Saturday or something, and then carve some of your other projects that you don't have a V-bit for, or that you don't need a V-bit for, you carve those on your other days when you're not using your free Easel Pro day. And then Easel Pro memberships, obviously you get access to v-carving all the time, anytime you want. You also get access to the 200 plus fonts that are in Easel Pro anytime you want. So those are just kind of like some of the differences. Even if you don't have an Easel Pro membership, we still want you to be able to carve and to still be able to use the features that are in Easel Pro, which is why if you have a machine, you can use Easel Pro for 4 days of your choosing every time. There's a support article if you're interested in learning more about that. We have a support article. We have a whole Easel Pro support section, and there's a, let me see, I'm trying to think of where it is. I probably should have done this beforehand. Yes, can I use Easel Pro for free? So this will show you, here is the button. When you go to click carve to carve an Easel Pro project, it'll say this, use 4 free carving days. Click that button to activate one of your days, and it'll give you a countdown for how much longer you have left on that day. We also do sell the day passes. So if you only want to use Easel Pro for 1 day, you can just purchase a single day for $2.99, and then you have access for 24 hours. And you can buy them in whatever kind of chunks that you want to buy them in. So day passes are also an option if you've really got to get a project done and you've used all your free days, you know, for $3, finish that project, make someone happy. It's an option for you. You don't have to buy a monthly membership or an annual membership to be able to do that. So I think that is everything I have for you guys today. I am going to put in down below here a survey because we've been doing Easel Live. This is our 16th episode of Easel Live. I can't believe that. That's a long time. I didn't think it was going to last this long, but we've been getting some good feedback from you guys, and we'd really like to know what you guys want to learn. So we had a lot of interest in the Carving Bits Easel Live episode we did, which I find crazy because I didn't think anyone would just want to like listen to me talking incessantly for like 45 minutes, but you're still here for some reason. So if you like these kind of projects at classes, I don't know, or if you want to see something like more concrete, like show me how to make something that's not a fidget spinner. I can't think of like anything at the moment. If you want to see like something specific, or you want to learn a specific technique, I'm going to add a survey down below. Give me like 5 minutes after the episode ends here to do that. But it would really help us out to know what you guys want to learn, because your feedback is what generates these classes. If we know what you guys want to learn, we want to teach you that. Otherwise, we might not be sharing things that you're even interested in learning. So it's really important to me and to everyone here at Inventables that you guys take that survey, help us out, help us figure out how to help you, and then we'll all be the best carvers that we can possibly be. So that's everything I have today. Again, if you want any of those resources that I've shared in this video, you'll find them down below. And also some really cool stuff, some videos from other people that I found useful when I was learning. That's all we have for you today. It's Friday, so I hope you guys have a great weekend, and I will be seeing you guys soon. Thanks for joining us.